Assalamu alaikum student. Today we are going to discuss the topic that is the nature of sound wave. Before we begin this, let me ask you a question. When you speak, does your voice travel from your mouth to your friend ear? It is only that the energy that travel. Many students think air move from the speaker to the listener, but that is not the correct. Only the sound energy that travel from the source to the listener. The air particle only vibrate about the original position. This is the nature of the sound wave. Air particle only vibrate about their mean position. Only energy, that is the transfer. But nature mean the basic characteristic or behavior something. So the nature of the sound wave tell us how sound behaves and travel. First, we know that sound is a mechanical wave. Mechanical wave can move through this medium. So sound wave is also a mechanical wave. Sound production, we need the vibration of the object. Without the vibration of the object, we cannot hear the sound. Sound is begun by the vibrating object. Example, if we take the guitar, vibrating string that is produce the sound, human voice, that the vibrating vocal cord that is produce the sound. And the third nature of the sound wave, that is the without the vibration, we cannot produce any sound. Okay, now we discuss the most important concept, that is the sound travel as a longitudinal wave. In longitudinal wave, the particle move only back and forth about their fixed position. Their vibration is parallel to the direction of the sound travel. This type of the wave is a longitudinal wave. Particles move forward. Here the particles of the air, when they move forward, this clouded region, that is called a compression. Here when the particle is moved forward, they make the compression. When these particles move backward, they produce the rarefaction. Rarefraction, the less crowded region, that is called the rarefraction. Most crowded region, that is called the compression. The less crowded region, that is called the rarefraction. We know that when the source vibrate, particles move forward and backward. When the particles move forward, they produce the compression in the wave. When they move backward, they produce the rarefaction of the wave. So in the longitudinal wave, continuously rarefaction and compression are formed. Longitudinal wave move as the compression and rarefaction are formed. In the compression and rarefaction, the particle move only back and forth, they produce the compression and rarefaction continuously. The travel through the medium has a sound wave. Another nature of the sound wave, that is the sound only transfer energy, not matter. Happen when the air particles vibrate. When the air particle vibrate, they only pass the energy from one particle to another. They only transfer energy from one particle to another. Particle only vibrate about their fixed position, and only that is transfer, that is the energy. So here we learn that the sound that transfer energy from one place to another without transferring the matter. What is the matter? That is the air particle, that is called the matter. Without transferring the matter, we only transfer the energy. That is the most important concept of the sound wave. In the sound wave, only energy that is transferred, not the matter is transferred. Another concept of the sound wave that we also learned, that is the sound cannot travel in a vacuum. Because sound wave is a mechanical wave. For the movement of the sound wave, we require any medium through which the sound wave can vibrate. But in the vacuum, no particles present in the vacuum. When the no particle present, sound cannot travel in a vacuum. That is all we discuss about the nature of the sound wave. Hope you learned this concept. Next, we discuss about the related terms of the sound waves. Now we discuss the related terms of the sound waves. These related terms of the sound wave help us to explain how sound wave behave. First, we discuss that is the wavelength. We know that where the particles are close together, this region is called the compression. The air pressure is high and air particle density, that is high in this part of the sound waves. Another part of the sound wave, that is called the rarefaction. In the rarefaction, the particles are far apart from each other. Here the air particle pressure is low, air particle density is low. Now come to the main topic, that is the wavelength. What is the wavelength? The wavelength is the distance between two consecutive compression or two consecutive rarefaction. If we here take the two compression, the distance between these two compression, that is the wavelength, and similarly the distance between the two rarefaction that is also called the wavelength. So here we write the definition. The wavelength is the distance between the two consecutive compression and the two consecutive rarefaction, that is called the wavelength, and is denoted by lambda, and its unit is meter, and it represented by small m. Next, I discuss the amplitude, represented by A. Amplitude is the maximum distance of a particle from the mean position. The distance of the particle is from the mean position is called the amplitude. Amplitude is the maximum displacement of a particle from its mean position. If any particle has the greater amplitude, it produces the louder sound. If particle has less amplitude, it creates the softer sound. That is all we discuss about the terms of the sound waves. Next, we discuss the frequency of the sound wave, the number of complete vibration that produce in 1 second, the unit of the frequency that is we use the hertz, and the unit of the amplitude that is the meter. That is all we discuss about the related term of the sound wave, wavelength, frequency and amplitude. Hope you learned this concept. If you learned this concept, please don't forget to subscribe my channel. Thanks for watching. Allah Hafiz.